Yes. So good morning, all. Uh,
Morning, sir.
in our last session, we talked about different kinds of two different types of random variable, discrete random variable as well as continuous random variable. After introducing that term random variable, we've gone for some of the specific terms like probability function, this probability distribution, and using that both the kinds of random variable, we had defined two different probability function, that is a probability mass function and probability density function. A probability function is known as a probability mass function if the random variable with which we are dealing must be discrete. And if we are dealing with the continuous random variable, then that probability function will be labeled as probability density function. So this was a discussion in last session, that means yesterday, and now we will move ahead with probability density function. We will start with the probability density function in this lecture. Then I will gonna introduce two new terms, that is cumulative distribution function for discrete random variable and cumulative distribution function for continuous random variable. And after defining this three term, probability density function and cumulative distribution function for both that random variable, ये तीनों definition discuss करने के बाद, after this definition, we will go for the examples of respective topic. So as you can see in your screen, first let me go for the probability density function. Now, before going to make you guys understand about this, I'll be happy if one of you will help me to make recall all the class a little bit with probability mass function. Yesterday we had discussed that about probability mass function. Probability mass function वो क्या था? अगर आप में से कोई एक ये रिकॉल करवा दे, उसको हम बोलते हैं PMF. What are the conditions that PMF will gonna satisfy? Or it will be also fine if you can deal with one of the example. I'm not worried about. I'm not actually looking for the definition or word explanation. It's okay.
सर उनका सम 1 होना चाहिए और ग्रेटर देन 0 और लेस देन 1.
First of all, Rishabh, ये बता. When I can say that probability function is a probability mass function.
सर उसमें प्रोबेबिलिटीज होती है, उनका सम 1 होना चाहिए.
नहीं. What I'm asking.
अच्छा.
Probability mass function is one of the specific.
Yes. Discrete random variable होता है सब.
Yes. When we are dealing with a discrete random variable, discrete random variable के साथ बात कर रहे हैं. In such a case, जो भी probability function हम define करेंगे, that probability function will be known as a probability mass function.
Yes.
Probability mass function was denoted by small f of x. Is it small f of x? Take care. Small f of x. Or that function is satisfying two conditions, that for each and every value of x, for every small x belongs to capital X, that that function should have value in the interval 0 to 1. Minimum it can take value 0. Maximum it might be 1, but can't exceed 1 or can't be less than 0. Good. This was our first property. What was the second one?
Summation of all the probabilities should be 1.
All that probabilities must be 1. Is it? If I am using one of the variable over there, one of the I running from 1 to f2, and then I have to denote f of xi, where I value of I is 1, 2, 3 up to xn. That means x1, x2, x3. I'm looking for f of x1 plus f of x2 प्लस एफ ऑफ एक्स थ्री अप टू जितनी भी पॉसिबल वैल्यूज है जो मेरा डिस्क्रीट टाइम वेरिएबल ले सकता है उन सब की प्रोबेबिलिटी का टोटल 1 होना चाहिए. These were two conditions for the probability mass function, is it? And we had also gone for two or three examples related to probability mass function. Now, instead of probability mass function, observe this definition. Today we will start our discussion with probability density function. Now, mass, that word is associated with discrete. That means indirectly we were dealing with the counting, is it? We were counting some of the data. Just try to recall our last example from the lot of 10 item. 3 items were defective, 7 were non-defective, and we were choosing a sample of 4 items randomly. And my random variable x was number of defective item in the sample. At that time, we were counting. We were dealing with counts, is it? Now, if I'm labeling my function as probability density function, that means what? I'm dealing with measurement. Measurement. That means I'm interested in measuring. In that case, my random variable should be continuous. मेरा random variable continuous होगा. Then and then I will be able to go for the measurements. Good. So, what is the definition of probability density function? Let x be a continuous random variable. Let x be a continuous random variable. Then the function small f of x. Observe both the notations are same. Earlier I was labeling with small f of x. Once again, the notation is same. It is once again small f of x. The function small f of x of random variable x is called probability density function if it satisfies two conditions. Now observe both the conditions are literally same. The first one, 0 is less than equals to f of x is less than equals to 1. That means once again the probability for each and every possible value of that random variable must be lying between the interval 0 to 1, close interval 0 to 1. Is it? For the all possible values of x, of minus infinite to infinite even, is it? And what is second? The integration running from minus infinite to infinite f of x dx must be 1. Now, why I'm using integration over here? What I'm saying, both these conditions are
Continuous
literally
value.
same.
It's a continuous value.
Okay, I'm interacting with Rishabh, might
Sure.
be. Yes, Rishabh. Yes. Why I need to use continue? Why I need to use integration, beta?
सर क्योंकि हमारे पास पहले डिस्क्रीट वैल्यूज थी तो हम समेशन कर सकते हैं बट इस टाइम हमारे पास कंटिन्यूअस वैल्यूज है.
Yes. You're absolutely correct. Now we are dealing with intervals, is it? And
Yes.
I wish, once again, I'm wishing the same. I need to add all that possible probabilities, but even I'm not in position to identify how many different values my random variable x gonna take. Is it? वो कितनी वैल्यू अज्यूम करेगा पता ही नहीं क्योंकि कोई भी दो वैल्यू के बीच में there will be infinite values. Between any two real number, there will be infinite real number. So in such a case, if we are not in position to list out all such possible values which random variable can take, and we need the summation and we need the addition of all of them, then we are having one of the tool with us. That tool is from calculus part of the mathematics, and that tool is integration. So instead of using summation f of x, we will be using integration running from minus infinite to infinite f of x dx. So both these are literally same. Here I'm interested in addition of all the possible values related to x. Earlier, we were doing the same. So instead of summation, we will take help from the integration. So this is just a small difference in both that properties. Earlier for the mass function, now we are dealing with the density function. So यही एक छोटा सा difference है, nothing else. And if we wish to find the probability for any desired interval from a to b, then we will be using this formula, integration over a to b f of x dx. Suppose if I'm wishing to find the probability that my random variable is going to take value between 1 to 4, x is having value between 1 to 4, then what I will be doing, I'll be using the integration formula, integration running over 1 to 4, f of x dx. For that, I will be in need of that particular probability function. Now that probability function will be provided in the question. Don't worry about that f of x. Okay, what will be the nature of this f of x? That will be provided in the data. Okay, so are we clear with this particular? Let me erase all things. So yes, are we good with this particular thing? All of you, let me know over the what. Let me know over the chat box. Are we clear? Okay. Okay, there is 2-3 message from the Alzar in the chat box. Sir, my mic is not working. And sir, I was trying to connect but not able to connect. It's okay. Alzar, I will be talking with you at the end of session. So be here. Kindly be here. Good. Now, after defining probability density function for the continuous random variable, we guys need one more concept, that is cumulative distribution function. That will be in my next slide. But before going for the definition of cumulative distribution function, let me make the things clear. Cumulative distribution function, we guys are going to define for two different variables. Cumulative distribution function for discrete random variable and cumulative distribution function for the continuous random variable. Is it? Now, instead of giving both the definition one by one, we'll be giving it comparatively. So it will be quite easy for you guys to understand this. So this is our next concept, next topic, that is cumulative distribution function. And after doing this, we will be dealing with kind of example related to density function and cumulative distribution function. Now, before going to define this term, can you able to explain what do you mean by cumulative frequency? क्या आप में से कोई एक बता सकता है what we mean by cumulative frequency? You already studied this particular in your high school. Frequency, cumulative frequency क्या होता है? शायद नहीं बता पाओगे.
सर वो
Wait,
जो
wait. Yes, Risha, please talk to me.
सर जो वो डिस्ट्रीब्यूशन होती है सर उसमें सब
रुक जा, मैं तुझे
फ्रीक्वेंसीज
थोड़ी सी
का.
help कर दूं. रुक जा ठंड पा. Let me help you a little. Let me give you one of the situation. Then I will be asking the same question to you. Then surely you will be in position to answer me. Okay. Suppose I had conducted one of the exam for the B batch,
ओके
one
ओके
of the exam for the PS subject for the B batch,
ओके
and that exam was of 50 marks. Okay, and
ओके
what I'm giving the data in the table. Let me tabulize that particular result क्या है वो मैं टेबल से आपको बता रहा हूँ. रुक जाओ. Here x, the variable x is representing the marks. Okay, suppose x is the marks of particular student. Now 10 means how many students got 10 marks in that examination. That frequency, that f is frequency, that frequencies might be, suppose 7 students got 10 marks. कौन से 7 नहीं पता, बाहर में जाए वो. What is the data I'm giving you right now? 7 लोग ऐसे, we are having 7 students in the class in this batch who got 10 marks out of 50. Okay, then after 20 marks, I'm having suppose 10 students with me who's got 20 marks in that particular examination, then 35 marks. Suppose I'm having 8 students who got 35 marks, and then after suppose 40, once again suppose 9 students are there who got 40 marks, and
यस
then after 50 out of 50, only a single student was able to secure 50 out of 50. So this is your frequency, is it?
यस
Now you can, might be you all will be in position to understand this particular data. This X represents the marks. This F is for frequency. That means 10 students are there. who got 7 marks. 20 students are there who were able to secure 10 marks out of 50. 50, sorry, that was, I think so. मैंने कुछ गड़बड़ कर दी बोल रहा हूँ. Okay, फिर से बोलता हूँ. 10 students were there who were able to secure 20 marks, and only one student were able to secure out 50 out of 50. Okay. Now, for this data, if we wish to go for the cumulative frequency, if I wish to find the cumulative frequency for this data, now Rishabh, you will help me. How to find
सर
that particular table? Yes, please.
सर 10 के लिए 7 होगी,
पहले के लिए 7. Yes, correct.
20 के लिए 17।
I need to add both this.
यस।
That addition will be here 17. Then I will
35 के
add
लिए तीनों
ये तीनों
25।
कितना हो जाएगा बेटा 25. Yes,
25।
perfect. Then after
उसके बाद ऐड 9,
cumulative frequency for the 40 marks will be
34।
34, and cumulative frequency for the 50 marks will be
35।
35. Is it?
यस।
उससे एक और बात भी तुझे पता चलेगी. You're able to know that in the class, in this
टोटल।
lab, we are having 35 students. Is it?
यस सर।
Is it? Okay, good.
यस।
So this was the thing we were dealing for the cumulative frequency. We were just adding the terms, adding that particular frequencies. Is it? Now the similar kind of stuff will be here. Earlier we were just dealing with some of the random marks or some of the random data. Now we guys will be dealing with random variable x, its probability distribution, and then we will introduce our cumulative distribution function. Now we guys are clear up to this step, up to this stage. हमको पता है random variable, if we are dealing with a discrete random variable, तो उसका probability distribution कैसे बनाते? We guys are good with that. Suppose my random variable is gonna assume some of the discrete value 1, 2, 3, and 4, and here is some of the respective probabilities of that. So this particular table, we are labeling this table. We are labeling this table as a probability distribution. We are good with this. Now, after finding that probability distribution, we will go for one more term, that is cumulative distribution function. Now, cumulative distribution function will be labeled by capital F of x, will be denoted by capital F of x. So take care about this notation. This is standard notation. You cannot change this notation. For the distribution probability function, sorry, for just probability function, we are using small f. For the cumulative distribution function, we will be using capital F. So this is standard notation. You cannot change this. Okay, we need to take care. Or if you're having that particular probability distribution with us, then it will be very, very easy to identify cumulative distribution. कैसे करेंगे चलिए देखते हैं. First of all, let me erase all this thing. But if you are having any query, any doubt, ये cumulative frequency जो हमने recall किया, इसमें कोई doubt है तो बताइए. Any of you, प्रांजुल बात कर मुझसे. अच्छा नहीं लगता जब तू बात नहीं करता. चल बोल, समझ में आया कि नहीं आया?
ये सर समझ में आ गया.
क्या बात है, तू तो काफी होशियार है भाई. ठीक है चल.
ये सर अरे समझ में आ गया सर.
ठीक है चल. Now what is cumulative distribution function for the discrete random variable? First let me go for that. Now first of all, we are dealing with the discrete random variable. That means my random variable x will gonna assume some of the distinct values. Let x be a discrete random variable which takes the values x1, x2, x3 up to don't know कहाँ तक जाएगा पता नहीं. Well, in such a form that x1 is less than x2, x2 is less than x3, x3 is less than x4, like that. Then the cumulative distribution function, observe here, the cumulative distribution function, observe the notation, capital F of x. The cumulative distribution function, capital F of x, is defined as f of xn equals to probability that my random variable x gonna take value less than equals to xn. Or, in other words, we will be adding all that terms from 1 to n. P of x1 plus P of x2 plus P of x3 plus P of x4, like this. That means what? If I wish to find f of capital F of x3, that means I'm finding cumulative distribution for the random variable x3. Then in such a case, I need to identify small f of x1 plus small f of x2 plus f of x3. Now, don't get confused in both this notation. Small f represents the probability. Capital F represents the cumulative distribution. Okay. Instead of using this notation, small f of x1, small f of x2, small f of x3, instead of using that notation, you may express like this also: capital X is equals to x1 plus probability that my random variable x gonna take value x2 plus probability that my random variable x gonna assume the value x3. Is it? Both these notations are good. We are good with both that. In some of the example, we will be using this kind of notation, but quite possible for some of the example, we are using this notation. So both these are okay. If I need to go for f of instead of f of xn, if I need to go for f of x4, then I will be adding one more term over here, f of x4, and plus one more term over here. Is it? So this is a simple definition related to probability, the cumulative distribution function, sorry. And these are some of the properties. This is quite basic. This is literally from the definition, so don't need to discuss that. Even we are good with that. Addition of all that probabilities related to that discrete random variable will always leads to 1, and the range of each and every will be always in the interval 0 to 1. We are good with all that. These are some of the basic property. We had already discussed that, so I don't wish to waste our time. Let me go for the, let me resolve the, sorry. Yes. Now, let's define the cumulative distribution function for continuous random variable. Now, before going for the next animation, can any of you will able to provide this definition? मैंने ये definition आपको बताई तो नहीं, देखिए. Is it? फिर भी पूछ रहा हूँ, क्या आप खुद से ये definition define कर सकेंगे? कोई एक, आप में से कोई एक. Will you able to define this term f of xn, where my x is continuous random variable instead of discrete? ऐसे भी लिख सकता हूँ, या तो I can denote like this: x is less than xn. Will you able to define this for me? Any of you? या तो ऋषभ बता दे, या तो प्रांजुल, या तो ध्रुवी बता दे, या तो मोहम्मद बता दे, या तो सैफ बता दे, कोई एक बता दे भाई.
समेशन की जगह इंटीग्रेशन का साइन है.
अरे भाई क्या बात है. चल इंटीग्रेशन लगेगा, पक्की बात है. f of x dx होगा, x and dx होगा. Now what should be the limit? What should be the limit? I am interested in that. इंटीग्रेशन लगेगा, पक्की बात है. ऋषभ, इंटीग्रेशन की लिमिट क्या लगाओ बेटा, ये भी तो पता चले.
सर लिमिट 1 से n - 1 तक होगी.
हो सकता है 1 से n. ओके,
n -1 तक.
n - 1
क्योंकि
नहीं,
सॉरी n होगी क्योंकि x must be equal to xn.
Must can be include xn. Good, but this is wrong beta. 1 तो गलत है. Now observe, we are dealing with continuous random variable, is it? For the continuous part, our interval is always minus infinite to infinity. We are always taking care for that whole line, minus infinite to infinite. So in such a case, we are not sure that our random variable will start with 1, is it? It's quite possible my random variable is going to take value 0 because it is continuous. It's quite possible that my random variable can assume the value 0.1, minus 2.3, minus 9.7, like that. So instead of lower limit 0, it should be minus infinite. So in the definition, it will be something like that: minus infinite to n, minus infinite to 2, minus infinite to a, like that. Now let me go for that particular definition. This is the definition. Yes. Let x be a continuous random variable, then the cumulative distribution function capital F of x. फिर से एक बार ये मैं fourth time आपको बता रहा हूँ. Take care about the notation. Capital F of x is the notation for cumulative distribution function. Then the cumulative distribution function for the continuous random variable will be defined as f of x equals to integration running over minus infinite to x. Why? Because I just used x over here. If I'm using x and if I'm using x up to capital X is less than equals to 5, then it will be minus infinite to 5. And okay. Might be one of the query will be here. Why I'd use f of t dt. So here I'm dealing with the definite integral, is it? And we all are very clear about some of the property of definite integral. When we are dealing with the integral with the limits, variable doesn't make any variable doesn't make any change. Why? Observe. If I'm looking for integration of x square over 0 to 1, क्या आंसर आएगा? That will be x cubed by 3, that means 1 by 3. That should be the answer. It will not matter if I look for integration of 0 to 1, y square dy. इसका आंसर भी 1 by 3 आएगा. 0 to 1, theta square d theta. इसका आंसर भी 1 by 3 आएगा. So, as I said, if we are dealing with a definite integral, then definite integral is always free from the variable. We are not worried we are dealing with x square, we are dealing with y, or we are dealing with theta, or we are dealing with t, or we are dealing with any of the variable. If we are having a limits for that integration, then surely that integration will end with one of the real number, is it? So instead of writing f of t dt, मैंने यहाँ पे f of t dt यहाँ पे t का यूज क्यों किया? बस इससे डिफर करने के लिए कि भाई ये x और यहाँ पे x जो है वो सेम नहीं है, is it? That depends on the limit of that particular continuous random variable. यहाँ पे मैंने लिखा है f of x is less than equals to x. That is the reason कि ये मैंने upper limit में x लिखा हुआ, और उससे कुछ अलग दिखाने के लिए I had used f of t dt. So take care. Instead of defining that way, let me define like this: f of x is probably that x is less than equals to, and then this will be minus infinite to n f of x dx. We are good with that, is it? So बात बस इतनी ध्यान में रखनी है. For the discrete random variable, we will be dealing with the summation, and for the continuous random variable, we will be dealing with the integration, because we will be dealing with interval of real numbers. And interval में तो infinite values होती है. So for that addition, we need the integration. Okay, are we good? Are we good? Your questions are welcome here. कोई डाउट है तो बताइए, जल्दी से बताइए. I am here. जल्दी से. Feel free to talk with me. Yes, any of you, please.
सर पहले तो आपने बताया कि उसका जो p of x less than n ये तो माइनस इंफिनिटी से इंफिनिटी होगा. लेकिन अब n क्यों?
कहाँ बेटा? ओके, यहाँ पे माइनस इंफिनिटी से इंफिनिटी होगा, लेकिन why I had fixed my upper limit as n, is it now? That is your question? Okay.
Yes.
Let me.
So I also have one question.
Yes, please. पहले तू भी बता दे चल. फिर let me.
Sir, property number 1, sir, please have a look on property number 1. You have
This
kept the limit from minus infinity to minus infinity.
वो
Why this?
typo है. Minus infinity to infinity होना चाहिए. That is a small typo. This is small typo. Okay. Frequency for the minus infinity. No. ये इसको मत, तू देख मत. अभी नहीं जरूरत. वो सही है, वो typo नहीं है. If you are talking about frequency for the minus infinity, then it will be always 0. वो क्यों, वो तुझे समझ में आएगा जब मैं तुझे नॉर्मल डिस्ट्रीब्यूशन पढ़ाऊंगा तब. डोंट वरी अबाउट दैट राइट नाउ. उसकी चिंता मत कर अभी. चल छोड़ दे. और कोई क्वेश्चन है बता.
नहीं, that's all.
ठीक है. चल. Now for the question of Mohammed, we are looking for cumulative distribution function, is it? Now suppose my random variable x is able to get is having a range minus infinite to infinite, as we said that it will be defined in minus infinite to infinite. And if I wish to go for cumulative distribution up to x equals to 2, x जहाँ पे 2 वैल्यू ले रहा है, वहां तक की ही मुझे cumulative distribution चाहिए. तो what I'm supposed to do? I'm supposed to add all this, na? I'm supposed to add all that probability that random variable x will take value less than 2. 2 से कम जितनी भी वैल्यू रैंडम वेरिएबल ले रहा है, उस सभी वैल्यू की प्रोबेबिलिटी को मुझे ऐड करना है. Yes or no? Am I clear?
Yes,
this is
sir.
what the definition of cumulative distribution. This is what the definition of cumulative frequency. यही तो हम कर रहे हैं. So in that case, if I wish to add this particular values, then my limits will be minus infinite to 2, surely. If I wish to go for minus infinite to n, then my limits should be minus infinite to n. Am I clear? और अभी कोई डाउट?
एक डाउट था.
और बता. डाउट है तो बता प्लीज. ऐसे नहीं बोल देना क्या क्लियर है. डोंट डू दैट.
सर अभी हम जब प्रोबेबिलिटी डिस्ट्रीब्यूशन लेते हैं तो उसमें जो मतलब सबसे लोअर लिमिट होती है सिर्फ वो माइनस इन्फिनिटी थोड़ी ना होती है, वो कोई एक नंबर होता है ना, जैसे कि हमने एग्जांपल ले लिया, कोई भी
हम्म,
एग्जांपल ले लो जिसमें
ले ले
स्टार्ट हो रहा है 1 से,
ले ले, हाँ ले ले।
स्टार्ट हो रहा है 1 से और एंड हो रहा है 5 पे, तो सर हम माइनस इन्फिनिटी क्यों लेते? तो फिर हमें 1 नहीं लेना चाहिए, माइनस
In
इन्फिनिटी की
that
जगह लोअर।
case, observe this particular. Observe the property number 4. If my random variable x is having a range a to b, अगर उसकी रेंज फिक्स ही है कि मेरा x है, सपोज कि मैं बात कर रहा हूँ मेरे रूम के टेम्परेचर की, कल हमने ये बात की थी। If my random variable is continuous random variable is temperature of my room, temperature of my room where I am sitting right now, और उसके लिए मेरे पास डेटा भी है कुछ, कोई अभी मॉनसून चल रहा है तो मिनिमम तो 20 डिग्री होगा और मैक्सिमम 35 होगा, इससे ज्यादा तो हो ही नहीं सकता, is it? So this is my lower limit, this is my upper limit. Random variable x इससे बाहर नहीं जाएगा, it will not exceed than 35 and 20 से कम भी नहीं रहेगा. So in such a case, तो भी जब भी हम कंटिन्यूअस की बात कर रहे हैं तो हम लिमिट तो माइनस इनफाइनाइट से इनफाइनाइट की लेते हैं कि भाई हो सकता है रैंडम वेरिएबल जो है रूम का टेम्परेचर वो माइनस इनफाइनाइट जा सकता है, गया नहीं वो बात अलग है, लेकिन जा तो सकता है. पर फिर विल बी वंस अगेन इंटरेक्टिंग विद द रियलिस्टिक सिचुएशन. ये माइनस इनफाइनाइट से इनफाइनाइट वाला केस है, उसको मैं माइनस इनफाइनाइट से इनफाइनाइट वाला जो इंटरवल है ना बेटा, उसको मैं मिनिमाइज कर दूंगा अप टू 20 to 35, and for the rest of the case our function will be 0. So for your question, Rishabh, I just need a next example, nothing else. आप छोटा सा वेट कीजिए, ये आपका डाउट अभी सॉल्व हो जाएगा थोड़ी देर में.
ओके
ओके ओके. व्हाट अबाउट मोहम्मद, आर वी गुड? आपको समझ में आ रही बात जो
हाँ
भी
सर,
मैं बोल रहा हूँ? आर वी गुड?
हाँ सर,
श्योर?
समझ गया।
Good, good,
यस
good.
सर।
And any other doubt from your side, any of you? Hello. I need the reply, huh?
नो सर, नो अदर डाउट।
Good, good. So let me go for the next one. Now, this is our first example related to, let me check, yes. In this question, we are supposed to check whether the provided function is probability density function or not. And if it is density function, then we are supposed to identify some of the density in one of the interval 1 to 2. So let's start. क्या करेंगे? Example 16 मैं समझाऊंगा. I will explain each and every small term of example 16. Then example 17 will be in your court. You guys will explain the example 17. Is it? Deal? Or you need, or you guys want to reverse the order? आपको 16 समझाना है या फिर 17 में समझा दूं? बोलिए जल्दी से. मैं एग्जाम्पल 17 की डेफिनेशन दिखाने नहीं वाला हूं भाई, आपको खुद पे भरोसा होना चाहिए. मी एंड यू और यू एंड मी? पहले आप करेंगे फिर मैं, या पहले मैं फिर आप? जल्दी से बताइए, जल्दी से जल्दी से.
सर दोनों आप ही कर दो,
सॉरी,
दोनों आप ही कर दो।
अरे भाई तुझे सो जाना है तो सो जा, चल. नहीं मजा आ रहा है
मजा तो आ रहा है सर।
तो फिर ऐसी बात मत कर कि दोनों में आप ही कर दो, आपको भी तो कुछ करना है. चल नहीं, डिसाइड कर लेता हूँ. Example 16 will be from my side and 17 will be from your side. Now what? What is the question? Check whether the following function f of x is a, I need to change the ink. Wait. I think so. You guys are good with the red color, is it? Red color देखने में कोई problem दिक्कत नहीं हो रही ना? I need to change the ink color. Reply
No,
Pranjul,
sir.
red.
It's fine, sir. It's fine.
Okay, good. So f of x is one of the function defined like this. F of x is e raised to minus x, 0. In what case it is e raised to minus x? Output e raised to minus x कब है? If my input x is my input is greater than equals to 0, तब output लेना है e raised to minus x. And if my input is less than 0, that means from the negative part, then my output will be 0. So this is the way the function is defined. That let me explain with line. It will make things clear in your mind. This is 0, this is minus infinite and this is positive infinite. And now 0. If my input, that means if my x is greater than equals to 0, यानी कि मेरा x इस रेंज में से है 0 या तो greater than 0 from this particular range, this part, यहाँ पे जहाँ पे भी x आप लेंगे वो या तो 0 होगा या तो it will be greater than 0. For all this interval, my function must have the output like this. It should be e raised to minus x. Okay, and for the rest of the part, that means if x is less than 0, that means if my x is from this particular region 0 या तो 0 से कम, sorry, not 0, but if it is less than 0, strictly less than 0, in all that cases my function f of x will give me output 0. F of x is 0 if x is less than 0. So are we clear with the function? Function समझ में आ रहा है? This is just a function, okay? This is just the function. Now what we supposed to check? Check whether this function is probability density function or not. Probability density function or not. क्या ये function है वो probability density function है या नहीं है ये decide करना है. And if it is density function तो कुछ और एक question है उसको बाद में decide करेंगे. Now first of all observe, we're dealing with the word density. Now that density function, probability density function, उससे हमको एक बात का बहुत ही clear समझ में आ रही है. We guys are going to deal with the continuous random variable. Or in other words, we guys are going to deal with the intervals, is it? So here is the interval. Both these are the intervals. Observe this interval. Instead of writing x is greater than 0, instead of writing that x is greater than 0, I may write like this. I may explain this particular as an interval that is 0 to infinite. And for this, I can express that particular from minus infinite to 0. So my f of x is e raised to minus x for the interval 0 to infinite, and my f of x is 0 for the interval minus infinite to 0. So that means we are dealing with the integral. That means we will be dealing with continuous random variable, and for the continuous random variable, probability function is known as probability density function. Now I need to check this function is probability density function or not. वो कैसे चेक करना है? हमारे पास दो प्रॉपर्टी है probability density function की. क्या है बता दे ध्रुवी, तू बता दे चल. What are that two properties that probability density function is having? उसके पास दो प्रॉपर्टी होनी चाहिए. क्या होनी चाहिए? जल्दी से बता, जल्दी से बता, जल्दी से बता. ध्रुवी तू है कि नहीं है? नहीं है. है रे, ध्रुवी तो है. हेलो, कॉल कट गया क्या? हेलो, नहीं बोलेगी भाई वो, जाने दे. तन्मय तू बताएगा बेटा? तन्मय, will you explain what are the two conditions that probability density function must be satisfying? तन्मय. हाँ तो फिर मेरे पास बात करने के के लिए दो ही लोग हैं, या तो प्रांजुल है या तो ऋषभ है. Anyone other than Pranjul or Rishabh will able to explain this?
Sir, f of x,
Yes, Mohammed. Yes, please.
f of x must be greater or equal to 0 and less or equal to 1.
Yes,
And the
probability
second
for
property,
each and every case that must be f of x must be greater or equals to 0, less or equals to 1. Yes. And second
property, f of x into dx integration of minus infinity to infinity must be equal to 1.
f of x dx must be equals to 1. Is it?
1.
So let's take the help from the second one. If it is a probability density function, then its integration from minus infinite to infinite must be lead us towards 1. उसका इंटीग्रेशन 1 ही होना चाहिए. तो चलिए देखते हैं क्या होगा. So we are checking this particular second property. इसको चेक करें कि इसका इंटीग्रेशन माइनस इनफाइनाइट से इनफाइनाइट एफ ऑफ एक्स का इंटीग्रेशन 1 आ रहा है कि नहीं आ रहा है. सो लेट्स गो फॉर दैट. माइनस इनफाइनाइट टू इनफाइनाइट एफ ऑफ एक्स डीएक्स क्या आएगा देखते हैं. चलिए. नाउ whether my f of x is continuously defined from minus infinite to infinite? No. Right now, as for the function provided in the data, my function is having two different type of outputs that depends on the interval. If I'm dealing with minus infinite to infinite, minus infinite to 0, that means अगर मैं negative part में deal कर रहा हूँ तो मेरा function का output 0 है. If I'm dealing with 0 or the positive part, then my output is e raised to minus x. So what we are supposed to do with this particular integral, we need to divide that integral into two parts. I will be dividing this integral into two parts, minus infinite to 0. वो पहले part के लिए देखिए, इस part के लिए for this particular region, minus infinite to 0 f of x dx. And for the second part, I will divide it from 0 to positive infinite f of x dx. Okay, so okay, किसी को problem है यहाँ पे मैं दो इसके I am expressing this interval as a addition of two parts. किसी को problem है? Are we having any issue? Okay, look, we are having one of the property of the definite integral. If I am looking for the integration over 1 to 2 x dx, then I may represent that as a 1.5 x dx plus 1.5 to 1.5 to 2 x dx. That will be totally fine. Is it? This is one of the property of the definite integral. इसके जितने भी टुकड़े करने कर सकते हैं 1.1 then after 1.1 to 1.5 1.5 to 2 बस that's all. Is it? So using that particular property, I had divided that integral into two parts. एक part रखा मैंने 0 minus infinite से 0, second part is 0 to infinite. Now minus infinite to 0. For that interval minus infinite to 0, my function is having output 0. So ये तो हो जाएगा 0. This will be 0 and integration of 0 will be 0. So that part will be not there anymore. Now, for 0 to infinite, that means for the positive part, my function is e raised to minus x. So I'm looking for the integration over 0 to infinite e raised to minus x dx. Now we know that integration of e raised to minus x is e raised to minus x divided by minus 1. That minus 1 will be here. So let me erase that minus 1 from the denominator. So that will be integration of e raised to minus x over the limit that is 0 to infinite. Now I just supposed to replace the limit upper limit then after lower limit minus. पहली बार x की जगह पे minus infinite replace करेंगे because I am having upper limit as infinite. So minus e raised to minus infinite minus lower limit minus e raised to minus 0 मानी कि e raised to 0. Now as per the one of the fact that e raised to minus infinite, the value of e raised to minus infinite is always 0. Why? Because e raised to minus infinite is nothing but 1 upon e raised to infinite, and we know that e is one of the constant 2.71. 2.71 raised to infinite is infinite. That means e raised to infinite is infinite, and 1 upon infinite will be always 0. So that is the reason e raised to minus infinite is 0. So replacing that e raised to minus infinite as a 0, here we will have 0. This minus minus will become plus, and anything raised to 0 will gives us 1. So this will be 0 plus 1, and answer will be 1. So that means this integration gives us 1. Minus infinite to infinite f of x dx is equals to 1. That means using that, we can conclude that a provided function, given function is probability density function. Are we good? Are we good? Am I clear? Let me show the way of presentation which you are supposed to follow in the examination. बता रहा हूँ मैं आपको, रुकिए. I cannot erase all things because I will be in need of the above diagram, above sketch. So let me erase some of them. Okay, good. So this should be the solution. Now go through that solution which I had just explained. क्या समझ में आ रहा है कि नहीं आ रहा है? Okay, वो second part तो बाकी रहने दो. Are you able to get this particular or not? Let me know or the chat box. Let's go through that solution step by step and let me know whether you guys are good with that or not. Drop the message over the chat box. Acknowledge. Kindly acknowledge. बताइए, बात कीजिए मुझसे। अरे भाई नहीं मजा आ रहा है तो सेशन एंड कर दो। बोल, are you able to get these things or not? No doubt sir. Any other? एक ही बच्चा पढ़ रहा है क्या मेरे साथ? दो तीन ही लोग तो जवाब दे रहे, एक ऋषभ, एक मोहम्मद और एक प्रांजुल। श्रीनारायण says no. Okay. राज पंजवानी, प्रीत लिंबानी, नैतिक जैन, जिग्नेश, हर्षवर्धन पांडे, दिव्यजीत, ध्रुवी, बेनिम लाको, अल्जर डाबा, आयुष बानुसारी, all. I need all the replies over the chat box. All of your replies over the chat box right now. Whether you guys are able to understand this or not, if you need any certain help from my side, then let me know. I will explain the things once again. But once let me know whether you guys are clear or not. ध्रुवी तू तो थी नहीं बेटा, मैंने तुझे बीच में 2 बार बुलाया. You were not attending. Guy was saying clear. Dhruvi, are you there? Can you unmute your mic?
यस सर.
कहाँ गई थी बेटा? ब्रेकफास्ट के लिए गई थी क्या?
नहीं नहीं, कुछ काम था इसलिए.
देख, तुझे लगा सर को पता नहीं चलेगा. Is it? ऐसा नहीं करना है. ध्यान रख. You must be here while you are attending the session. और तो कोई बात ही नहीं हुई. जिस बात की तो ये सब बेकार है. Okay, so now, were you able to give me? Yes, this is a probability density function, as we had just identified. The provided function is probability density function. This was our first question, first part of the question. Now, if it is probability density function, if so, yes, it is probability density function. Then what we are supposed to find the probability that the variable having this density falls in the interval 1 to 2. Now we are just supposed to identify about the density from the interval 1 to 2. For that, what we need to go for, we just need to identify integration over 1 to 2 f of x dx, because right now we are dealing with one of the specific interval. ऋषभ देख यहाँ पे, अब बोल रहे हैं कि भाई x की वैल्यू अगर 1 से 2 के बीच में ही है, कम से कम 1 हो सकती है, ज्यादा से ज्यादा 2 हो सकती है, तो आप उसके लिए प्रोबेबिलिटी density find कर सकेंगे कि नहीं? हाँ कर सकेंगे, because we are having probability density function with us and we are just interested in this range 1 to 2 only. So what we need to do, we need to just go for this particular integration, probably that my x is lying between, now I need to, probability that my x is lying between 1 to 2, it will be integration over 1 to 2 f of x dx. And once again, observe that 1 to 2 in interval 1 to 2 will be something over here. Here is 0, here is 2. So 1 यहाँ पे कहीं होगा. चलो ये 1 है, ये 2 है, मान लीजिए this is 1, this is 2. Now we are just dealing with this small interval. That interval is actually subset of 0 to infinite. So we are knowing a function for the range 0 to infinite, and 1 to 2 is one of the subset of that interval. So for that interval 1 to 2, a function f of x will act as the same, e raised to minus x. E raised to minus x, as it is given in the data. So we just need to once again integrate e raised to minus x with respect to x. E raised to minus x, it will be e raised to minus x and minus into minus, and over the limit 1 to 2, we just need to calculate e raised to minus 2, e raised to minus 1. Now this thing is very, very easy for you guys because scientific calc is allowed, and that scientific calc is having one of the function key for the exponential power, whether you want any positive or negative power for the exponential, then you can do that just by 2-3 taps, small taps, is it? So the answer will be 0.233. We are not worried about this calculation right now. वो कैलसी से हो सकता है. So are we good? Should I give you the next question? कोई डाउट है तो बताइए, वरना जो अगला क्वेश्चन है वो आप सॉल्व करेंगे. I will be interacting with all of you, any of you, randomly. If you are not attending this session seriously, then I will advise you leave the session right now. I just want all those students who are really attending this session, because I am giving my best. I'm trying a lot to make you guys understand. And on the other hand, if you are just doing some other works, random works in some other tabs, then it will not work. will not help me. So this is example number 17. Now, for the following probability density function, for random variable x, find the value of k and probability that the random variable is having probability density function will take on the value between 0.1 and 0.2 greater than 0.5. Now here we are not checking whether the provided function is density function or not. Observe the question properly. Let me explain the question first of all. This is one of the function provided in this example. Oops, sorry. Okay, my pad was a little bit disturbed. Now, this is the given function, and the information is that this function is probability density function. ये probability density function है ये. We are not supposed to check. Observe. For the following probability density function. So it is given that this function is probability density function. In that function, we are having one of the unknown k. K is over there. K times 1 minus x square if my random variable x is lying between 0 to 1. And for rest of all the other cases, my f of x will have the output 0. So देखिए इसको भी मैं एक बार explain कर दूं. For this particular example, this is minus infinite and this is positive infinite, and suppose this is 0, this is 1. If my x is lying in this interval 0 to 1, इस interval में है, in this case my f of x will act as a k times 1 minus x square. K times 1 minus x square. In the rest of all the portion, for this portion where x is greater than 0, यहाँ पे f of x 0 है, f of x is 0. Even for this portion, if x is less than 0, यहाँ पे भी f of x 0 है. For all this portion, f of x is also 0. Is it? So this is the actual scenario with the function. Now we need to identify the value of k first. This is already probability density function and we are looking for the value of k first. चलिए पहले k की value बताइए क्या होगा k. What should be the value of k? Now your time starts now. If you are not getting the question, then you may unmute yourself and talk to me. Else you are supposed to deal with this question. I'm waiting. I'm giving you 2-3 minutes. I'm waiting for your answer. I need the value of k over there. एक छोटा सा इंटीग्रेशन आपको करना है, उसको इक्वेट करना है 1 से, because this is a probability density function that is provided. Mohammad Yasin is saying yes, it is. The value of k is 0.1. Correct, beta. Mohammad Yasin, what you will do, you will go for next question. That means value between 0.1 and 0.2, and then after greater than 0.5. Try that, both that. I'll be choosing randomly from the audience, okay? And might be I will be asking for your screen sharing even. So all of you must be trying. Okay. Mm, Preet Limani, may I know your status? What is the value of K? Preet Limani. Preet Limani. Preet Limani, if you are attending this session, then kindly unmute yourself and talk to me, or in other case, just drop a message over the chat box, but at least acknowledge. Preet Limani, are you there? Okay, might be he's not there. Let me remove him. Preet is not there. I will gonna remove each and every person who is not gonna reply me. Okay. Now, Jignesh Prasad, are you there? Jignesh, go ahead, ruk ja. Alza Daba. Alza Daba, are you attending the session? Alza? Alza Daba, are you there? Okay. Have you gone for the last example which I had provided? Example, this particular example number 17, which we are discussing right now. Are you in position to give me the value of K? Yet you are trying. Okay, I'm waiting for your answer. I will be get back to you once again after just 2 minutes. Benim Lako, unmute yourself. Benim Lako, unmute yourself and talk to me. Benim Lako. Benim Lako, are you there? Benim Lako. If you can hear me, then please unmute yourself or drop a message or the chat box. Okay, in such a case, can you able to share your screen with us, all of us? If you are trying that particular equation, then we guys are interested to know the way you are trying. Can you unmute, or you may you in position to share your screen with all of us, Benin, or is there any of you? It will be good for us if you can show your solution or your the way you are trying for this question. I'm waiting for answer from your side. Okay, I'll be get back to you once again. Wagai Kusha, Wagai Kusha, are you there? Attending the session or not? Yes. Okay. Have you gone for this particular question? Are you able to find the value of k? I'm interested to know for what value of k this function will act as a uh, probability density function. Okay, how it's 1.1? Why? Why it's 1.1? Can you explain? Kindly unmute yourself. Unmute
So
yourself
we have
once.
to check that condition, no?
You have to check that.
Check the condition. Told that it is
Ranjul, your voice is backing in between and lots of disturbance from your side. So try to reconnect. Yes, I was interacting with Vagai. Vagai, can you unmute yourself? Vagai, now it's needed. Vagai, either unmute yourself or on your webcam, or if it's not clear, it's okay. It's okay. I will make that things clear. Once you are sharing your screen with me, I will help you to uh, clear all that things. I will able to know at what stage you are committing some of the mistakes, and then I will be correcting you. I'll be helping you. Vagai, can you share your screen with us, or can you unmute yourself and talk to me? Or third option, can you on your webcam?
Yes, sir. I'm
Yes.
sharing my screen now.
Okay, Vagai. Yes, there you are. Yes, please. You may share your screen from cell phone, even from the laptop. Also, I have given all the rights to all the attendees. Yes, here is the Vagai screen. Yes, Vagai. Now go to gallery. If you had clicked that particular pic.
Sorry, sir.
Okay, now let us show
Rest of
you. Have you tried for that question or some of
no,
the notebook?
I haven't got the concept, sir. Uh,
Then it's meaningless to share your screen. Okay, stop your presentation. Stop your sharing. I just thought you had tried for that particular question over some of the notebook, and you will gonna click that question, and then you will share with all of us. Is it? That is what you were supposed to do. Now it's okay. It's fine for this particular time. Once again, my screen is visible to all of you. Yes. Naitik Jain. Naitik. Wagai, kindly mute yourself, Wagai. Your mic. Okay, yes. Thank you, Wagai. Yes, Naitik. What's your answer for the K?
Sir, K is going to be, so for first, okay,
Yes, for the first part, that means we are interested to know the value of K.
yes. Sir, 2 by 3.
2/3. How? कैसे? कहाँ पे गलती कर दी बेटा?
So we'll just integrate from 0 to 1. Oh, we have to integrate from point 1 to point 2.
No point, not from point 1 to point 2. We have to just integrate from 0 to 1 for the value of K. Be with me, be with me. Also be with me.
1 minus 1 by
Just be
3
with me. Look. Just be with me.
x
Okay?
minus 1 by 3.
Wait, Nitik, be with me. Here is the solution. Observe. As we know that the function f of x is probability density function, that means integration from minus infinite to infinite f of x must be 1, is it not? As per the property, this integration must lead us towards 1. Now, minus infinite to infinite, for that particular, this particular question is having three different kind of function output. For the interval minus infinite to 0, our functional output is 0. For the interval
Yes.
0 to 1, my function is having output k times 1 minus x square. And for 1 to infinite, our function is once again 0. So what I'm doing, I'm dividing this interval into three parts, minus infinite to 0, then after 0 to 1, then after 1 to infinite. In earlier question, we had divided that interval into two parts. Goes as per the
Yes, we have to
situation.
equate it. So 3 by
Now,
2.
yes, the answer should be 3 by 2. Might be you had committed a small mistake. Might
Yes,
be
I
a
didn't
choti
had
si mistake.
equated it equals to 0. So I had
Yes. You cannot equate it to 0 because as per the rule, as per the property, that
it
integration
is
must
equals
be
to
1.
1.
So it should be 3 by 2. So this is a solution for the first part. By that way, we can identify the value of k. The value of k will be 3 by 2. Now, all the attendees, kindly go through. Naitik, mute kar apne self ko. Naitik, kindly mute yourself. Now all the attendees will go for will see the solution once. Agar if yet you are having any issue, yet you are having any doubt, wagaye, then let me know. Now, if you are not able to understand this particular, then please let me know. I will explain it further. But kindly acknowledge or the chat box whether you guys are able to understand this or not. नहीं समझ में आ रहा
सर
है तो
एक
भी बताइए.
क्वेश्चन था सर.
हाँ बता दे बेटा.
सर जैसे एक प्रोबेबिलिटी डिस्ट्रीब्यूशन है सर, ठीक है, एक प्रोबेबिलिटी डिस्ट्रीब्यूशन फंक्शन है, उसमें अगर कुछ रेंज ऑफ वैल्यूज के लिए वो क्या कहते हैं, कंटिन्यूअस है, मतलब ये प्रोबेबिलिटी डेंसिटी फंक्शन है कुछ पार्ट में, तो
It will be mix.
मतलब
That means you are talking about mixture of continuous and discrete, is it?
हाँ,
Okay.
तो
For
सर
that.
उसमें
हाँ
हाँ
बोल. हाँ बोल
तो
आगे
सर
बोल.
फिर वैसा केस पॉसिबल अगर हो तो फिर उसमें सर मतलब अगर पूछा है कि क्या है तो मतलब वैसा पॉसिबल है कि नहीं, पहले तो मुझे वो भी नहीं पता.
है पॉसिबल है.
हाँ, तो
But
फिर सर अगर
we will
उसमें पूछा
be
किस
not
टाइप का डिस्ट्रीब्यूशन है तो क्या बोलेंगे?
for such kind of situation. That particular situation is not included in our syllabus. But for the realistic, it is possible. For some of the range, my random variable will gonna take value of in the continuous form, and for the rest of the things, for the rest of the interval, it will be act as a discrete. So we first of all we are not gonna learn that kind of stuff in this syllabus. Okay, but if the situation is like that, then we need to deal with both of them separately. जहाँ पे कंटिन्यूस है वहां पे हम कंटिन्यूस के हिसाब से उससे बात करेंगे. जहाँ पे डिस्क्रीट की तरह एक करा है वहां से डिस्क्रीट की तरह बात करेंगे. लेकिन in that case we need to have the relation between both of them, and that is very advanced in this particular subject. That topic is very advanced. To reach up to that particular point, we need to learn lots of things, is it?
ओके सर.
But ये भी बात सच है कि इस syllabus में वो आएगा नहीं, is it? Because that is very advanced. But yes, it is possible.
ओके सर.
For your question, yes, answer is yes, it is possible.
ओके.
Now, so if my value of k is 3 by 2, then here is my value of k. K is 3 by 2. Now my function was earlier defined as k times 1 minus x squared. Now I'm just replacing k over there. The value of k is 3 by 2, so I'm replacing k over there. So now my function will act like this. Function is 3 by 2, 1 minus x squared, and 0 in the range 0 to 1. The output is 3 by 2 times 1 minus x squared. In all the other cases, the output will be 0. Now, this is my function. It is probably the density function. Now, we need to identify that what is the probability that my random variable, what is the probability that, where is the pen? Yes, here it is. What is the probability that my random variable x is going to take value between 0.1 to 0.2? Now, that is what my second part is. Second question is, we are looking for, here is that particular between 0.1 and 0.2 इसकी probability क्या होगी? So we are looking for this, and for that what we need to do, we just need to go for one of the integration from 0.1 to 0.2 over the function f of x. Now f of x is, now observe 0.1 to 0.2 is the subset of this interval 0 to 1. So my function will act as 3 by 2 times 1 minus x square. So it will be once again 3 by 2 times 1 minus x square dx. और ये छोटा सा इंटीग्रेशन करेंगे and we will able to get the value of value of x lying between 0.1 to 0.2. And if we are interested for the third case, greater than 0.5, this is the third one, greater than 0.5. For that, what we will do, we'll look for the third one. Let me write it here. Probably that x is greater than 0.5 means what? We are looking for the integration. Lower limit इसकी होनी चाहिए 0.5. Upper limit should be infinite. It's greater than 0.5. माने कि 0.5 से बड़ी कोई भी value. That means 0.5 to infinite. F of x dx. Now instead of writing a 3 by 2 1 minus x square, I'm writing f of x over there because I'm not having my function continuously defined from 0.5 to infinite. For that 0.5 will be something around here, 0.5, and right now I'm looking for 0.5 to infinite. So I need to divide that interval into two parts, 0.5 to 1, and then after 1 to infinite. For the part 1 to infinite, my function will act as 0. That I had included in the next slide over here. This is for the second one, 0.1 to 0.2, and this is for the third. Yes, that is what I was discussing. If I'm looking for x greater than 0.5, then as per the, let me choose the pen. Yes, it is. As per the data, my function is just defined between 0 to 1. And now for this particular range, my function is f of x equals to 3 by 2 times 1 minus x squared. And recently, we are interested to find for this particular x is greater than 0.5, that is 0.5 to infinite. That means we are interested in this region, 0.5 to infinite. अब यहाँ पे भी function का दो अलग nature है. यहाँ से यहाँ तक f of x is like this, and for rest of that part, f of x will act as a 0. So I need to divide this interval into two parts once again, 0.5 to 1. F of x dx, and then after 1 to infinite f of x dx. For 1 to infinite f of x dx, my f of x is going to act as a 0 like this. So this part will be not there more. This will be 0. This 0 is for this. And for this part, f of x will act as a 3 by 2 1 minus x squared. So once again, the similar kind of integration will be there. And by solving that integration, we will be able to get the value of 0.3125. So once go through this particular and let me know whether we are clear or not. If we are clear, then I'm good with that. Clear, sir. Okay. It is clear. Okay. Srinarayan, clear. Okay. Rest of the students. Saif Ali, Samir, Wagai, Dibyajit, Dhruvi, Darshan, Bhakta Darshan, Chiknesh, Mohammed, Tanmay, all of you are supposed to reply over the chat box. Arjun is there, okay. Alzar. I'm glad to know that Alzar is getting these things. Alzar, surely you are in position to understand all these things which we are discussing right now. Alzar, surely you are able to get all these things which we are discussing right now. Yes, sir. Good. That's good.
Sir,
Yes.
sir, can you please explain that part again for the first one? I mean, only first part.
Only first part means for the
F
third
of x
question.
dx. Yeah, which question? F of x dx from 0.5 to 1 plus f of x dx from 1 to infinity. That only this one.
Why I had to divide that interval into two parts? Is it?
Yes, yes,
Is this your
yes.
question? Okay. Okay. Be with me, Mohammed. Observe what is the scenario right now with us. We are looking for the probability that my random variable x is gonna take value greater than 0.5. Is it? Now, if my random variable is gonna take value greater than 0.5, that means what? I'm looking for probability of x is greater than 0.5 as I written over here. Is it? Now, as per the
Yes.
definition of continuous probability density function, it should be 0.5 to infinite. Are you clear with this? Why I had used this limits
Yes.
0.5 to infinite. Okay, that means we are looking to find all that values which are lying between 0.5 to infinite. That means we are interested in all this interval, is it? We're trying to get all that probabilities and we need to find its summation. We need to find its summation, is it? Now, for this
Yes.
part, 0.5 to infinite, is function is that function is in continuous form? No, it is not in continuous form, because my function is defined in such a way that f of x equals to 3 by 2 times 1 minus x square. But when, if and only if my random variable is lying between the range 0 to 1, this definition is just for 0 to 1. If my input is, that means if my x, random variable x, is lying between 0 to 1, then and then my function will act as a 3 by 2 times 1 minus x square. In all the other cases, my function will act as a 0. Otherwise, that means in all the other cases, if x is greater than 1, if x is less than 0, in all such cases, my function will act as a 0. So what I'm supposed to do now, I'm just interested in this part. Wait, let me erase this particular. Now, using that particular scenario, I'm just interested to find my value between 0.5 to infinite. Now we are just looking for, suppose here is 0.5, this end is infinite. We are interested to find this particular, is it? Yes or no?
Yes. Yes.
Good.
Yes.
Till 1. Between 0 and 1, suppose here is 0. Between 0 and 1, my function is having some of the different nature. It is 3 by 2 times blah, 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 1 minus x square. And from 1 to infinite, my function is having different nature.
Yes.
In this
Yes.
case, my function is having value
0.
0. Is it?
Yeah. Yeah.
So I cannot directly go for 0.5 to infinite. I need to divide that interval in such a way that
Yeah. Yeah.
in both the cases, my function is defined. Is it? I must have the definition of my f of x. Then and then I will able to go for the integration. Yes or no? If I'm not
Yes.
able to define my f of x for some of the interval, then how I will move for the integration? For that, I need to divide this integral into two parts, 0.5 to 1, then after 1 to infinite. And for this part, 0.5 to 1, 0.5 to 1, my function is 3 by 2 times 1 minus x square. It is provided in the data. So for this particular integrand, my function will act as a 3 by 2 1 minus x square as it is. Observe the limit 0.5 to 1, 0.5 to 1. Is it?
Yes.
And for this
Yes.
part, if my x, that means if my input is greater than 1, then my function will act as a 0. So if my integrand is 0, here f of x will act as a 0. If my integrand is 0, the integration of 0 will be 0 and the limits will be meaningless. Is it? So this will give
Yes.
us 0. And the rest of the thing is just the simplification of this term, nothing else, a simple
Yes. Sir, got it.
integration. Got it. Good, 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 good.
Thanks. And sir, can you show the solution? I mean the answer for the first part. I don't know
Okay,
if
yes. Why? Why? Why?
I
Why
want to
not?
check.
Why? This one?
Yeah. Yeah. Sure. Sure.
The
Okay.
answer for the
Okay.
first one is 0.1465.
Yes. 0.1465. Yeah. Okay.
And the answer of K is 3.2. Answer of,
1.5.
sorry,
Yeah.
3 by 2, that means 1.5. Answer of K was, let me mention over here, yes. Answer of K was 1.5, that means 3 by 2 for the first part. Second question, that is for the value of K. Then after first answer, I have 0.1465. And the answer for the second question was 0.3125. Okay, so take care. Hopefully, we guys are good with this, is it?
Yes, sir.
Okay, Divyajit is recalling me about you have to upload the PPTs. Okay, Divyajit, I will do that after the session. So it's already 11:20. I think so. It's a quite a heavy dose for you guys for the day. Should we go for the next example or I need to continue in the next lab? Choice will be yours. अब तो रिप्लाई कर दो भाई. अब तो रिप्लाई कर दो. हाँ, कौन बोला?
नेक्स्ट लैब सर सर नेक्स्ट लैब
सेफ तुझे कब से बुला रहा था, तब तो तू आया नहीं.
सर
Minimum I had called you 3 times during the session. You were not there to reply me. okay. So should we continue in the next lab? Okay, 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 good. So let me stop the recording over here. Okay, if you guys are not clear with the session, then kindly go through this video. This video will be available over the YouTube, and you will be having the link of this video with the help of your login. आपको login में से इसकी link मिलेगी. So if you are not clear, the things is not clear, then kindly will revisit this video, go through it once again. The things will be surely clear because I tried my best to explain these things. Okay, let me stop the recording over here.